The next step after erecting the timber frame is to install the structural insulated panels, or SIP panels. The panel manufacturer has provided pre-cut panels, a detailed panel layout plan, all the required adhesives, fasteners, foam, plywood splines, and, in some cases, lumber for edge blocking. In this video, we will go through the steps of installing the panels, review best practices, and offer tips and guidelines. A crane is the best option for installing, although the lower wall panels are effectively done by human power. With some ingenuity, the upper wall panels and roof panels can be done by hand as well. A lull with a boom attached, such as the SkyTrack used in this video, or an excavator may work well. But it depends on the height of the building, the skills of the operator, and the crew on the ground. The owner's manual contains extensive information about the panels, including panel types, construction details, finishing options, and building science recommendations for siding, roofing, window installation, and ventilation. You should be familiar with this information before starting on the panel installation. In addition, your architectural plans will show building sections and wall sections which have specific panel details at the sill and eaves. And finally, the panel layout plan has at least one full page of specific details in addition to showing where each panel belongs in your building. Review the panel plans before you get started. Get familiar with the panel numbering and sequence. You will receive several documents with your panel package. You should have a panel layout plan, which shows the timber frame outlines and the panel layout sequence. You will also have a panel pre-cut plan and a bundle list showing where to find any panel by bundle number. Each bundle of panels also has a contents sheet attached that shows which panels are in that bundle. The panel layout plan includes a 3D view of the project, which allows you a visual reference of the finished product. The drawing legend shows all abbreviations, line types, route schedules, panel types, and panel identification tags. Understanding these abbreviations and tags will help you to quickly navigate the plan and identify the panels you need. The wall panel surface layout page gives you a plan view reference of the project with elevation tags for each face and arrows that tell you the surface number and on which page to find the panel layout. It also gives you a reference for where the panels join and overlap. Likewise, the roof panel layout page gives an overall view of the pattern and where the panels join. There may be an elevations page that shows the wall panels in elevation view. After that, the detailed panel layouts are presented as surfaces with each panel number, window and door location, and panel overall dimensions. The timber frame is also represented in a lighter color line, so you can see where the panels go in relation to the frame. The roof panel layout page works the same way, with panel labels indicating the surface and number. There will be at least one or two pages with construction details, showing how to construct the sills, joints, splines, corners, and openings. Pay particular attention to the red dots, which show the sealant applied to all foam to wood surfaces. There are details that specify fastener installation and spacing, how the corners are built, and how the roof meets the walls. There is a detail called Panel Eave Connection Detail that you will need to study. It shows the distance the roof panel extends beyond the outside of the wall panel. We will cover this in more detail in the roof panel section of this manual. There are two products that will be used to seal the panel joints: spray foam and panel mastic, or sealant. The spray foam is supplied with an applicator gun and is used to fill gaps in foam channels. A close look at the details for corners, eaves, rakes, and ridge will show a half-inch gap that is to be filled with foam. That gap may be wider because it is equal to the thickness of the furring or wall material applied behind the panels. On roofs, it is typically 3/4 of an inch, which is the thickness of 1x8 T&G pine. All panel-to-panel joints on the walls and roof are sealed with foam, applied using the drill and fill method, which involves drilling holes at specified distances and injecting foam into the foam channel of the panel edges. We will look into this process in another video. The panel mastic is a special type of caulking made to bond to the foam core and is used to seal between any wood edge fillers. Window and door fillers, and at the sill plate or on a subfloor. Anywhere the panel insulation meets wood in direct contact should be sealed with panel mastic. Another use for the panel mastic is joining field cut panels. Wherever a panel scrap is used, the cut will not have a foam channel. Lay 2 beads of panel mastic on the edges and push tightly together to make a good seal. Before installing the panels, you will need to pre-install the drywall or install furring strips, which will allow drywall installation later. In any case, the face of the timber frame should be flush to the face of the rim joist at every post, but this doesn't always happen. Being that the wall panels will be screwed along the bottom edge into the rim joist just above the sill, the ribbon band or furring strip should be nice and straight all the way to the sill. If not, the panel bottom will be pulled in or bulge out at the bottom, creating problems for the siding and exterior trim. Check this using a straight edge. If the wire chase gap is greater than 3/4 of an inch, you can use thicker stock or layers of thinner stock. If there's a severe taper, you may want to rip some 2x stock or a taper to match. If you have used a 2x12 for your sill and left it wide, now is the time to measure it out 4.5 inches from the chalked line and rip it off. If the remaining dimension is less than 4.5 inches, you will need to build out the edge so it becomes flush to the panel face. Before any panels go up, you also need to install wires for any exterior floodlights or other fixtures that you may want. There is detailed information on wiring in the wall panel and roof panel installation sections of your manual. Panel installation day has arrived. You may begin with a gable or an eave wall. It's up to you. If a wall has a lot of small cuts for some reason, save that wall for last, which will save time in digging through the piles looking for the cut panels. Some wall panels can be installed by hand, with 2 or 3 workers moving the panels into position, placing the bottom edge of the sill plate and tipping the panel up into place. This is fine as long as you have a good level surface to walk on and easy access to the materials. It's more likely that you'll need to lift at least some of the panels and definitely all of the upper panels with a crane, lift, or extra manpower and ropes. The tools you'll need to have on hand are listed in your manual. The best place to start is on a corner. One face of the corner will have the panel flush to the frame and the other face overlaps. It's usually easier to start with the face flush to the frame. The panel numbering sequence will start on one end, usually left to right, and it makes sense to start there. Mark the edge of the starting panel on the panel ledge before laying down the bead of sealant. You should only lay out as much sealant as you can cover with the panel you're installing. Don't get too far ahead with the sealant, it gets messy. Find the chosen panel and put it on sawhorses near its final destination, exterior side up, with the foot of the panel facing the building. Look at where the panel will land on the frame. Wherever it contacts the frame, you will be inserting screws. It's a good idea to start the screws in advance to save time and help get the panel secured quickly. While the panel is on the horses, mark out the location of the ribbon band, any posts, and the upper beam or tie. Position the screws, use 7-inch screws for 4.5-inch panels, along the bottom edge, through the ribbon band, the top edge, a beam or tie, and into any posts that the panel may land on. Check your panel plan for exact details on screw spacing. Screws are usually 10 inches on center, so 5 across the bottom and 5 across the top. If the panel is half bearing on a post, keep the screws 2 inches from the edge. They need to miss the groove for the spline, but hit the post. You might want to angle these screws slightly. If there is a knee brace, you can lay it out to get 2 screws in it. Note that the screws are pre-positioned on the ground before standing the panel. This saves time and makes ladder work safer. Some people prefer to simply drive the screws with a drill or driver. Others have found that starting the screws with a hammer speeds up the process. Or you can drill starter holes for each screw. Some builders find this quicker and easier as the screws tend to vibrate and bounce when hit with a hammer, depending on the hardness of the OSB used on the panels for each building. We simply laid a scrap piece of furring strip across the panel and drew a line before drilling. The first strip is just the width needed to put the line where it needs to be, without measuring each time. Or use a drywall square at the position needed and drill along it, or mark a line along the square and drill on that line. Then, just push the screws into the foam at the angle needed, and they will be held in place for when you're on a ladder or leaning out in the air, and only have one hand available to drive them in with your drill or driver. Remember to use the supplied 7-inch screws for the 4.5-inch wall panels. The longer screws supplied are used on the thicker roof panels. Splines are strips of plywood or OSB that are supplied in a bundle and are used to join the individual panels together to create a continuous surface. The spline is inserted into the channel cut for it by the factory. Most installers find it easiest to put up 2 or 3 panels, then go back and slide the vertical splines down into the slot from above. Make sure the slot is completely filled. The splines can be screwed or nailed with a nail gun to finish. Sometimes it's helpful to screw one edge of the spline into place in the panel while it's still on the ground, pulling it up flat to the backside of the panel OSB. This aligns things so that the next panel slides right over the spline without jamming. Other times, it's best to leave the spline loose and jiggle it into place. Also, running a power plane or circular saw down the length of the spline on a 45-degree angle, beveling just the corner of the spline, helps the spline to slide into the next panel. At windows and doors, make sure the spline is down to the bottom of the foam route, not the edge of the OSB opening, or it'll be in the way of the 2x you'll insert later. Note how in this photo, the vertical spline is pushed all the way into the foam groove to leave room for the horizontal spline to cross above it. Note the edge is beveled for easier joining with the abutting panels. If there's a horizontal seam at the top of the panel, make sure that the vertical spline is below the bottom of the horizontal groove. In some cases, the splines are not accessible after the panel is installed. On the gable ends, the wall panels are usually stacked on top of the other. In that case, the spline must be attached ahead of time. You don't have to nail or screw the splines right away. Most installers find it faster and more productive to leave that part until a section is complete, or even until after all the panels are installed. This way, if you need to make an adjustment or fix a mistake, the panel screws are easily backed out and the adjustment can be made. It's better to make sure everything is just right than go around and button up the panels with a nail gun or screw gun. It's much harder to fix something after the splines are nailed off. Start on a corner and determine if the panel will extend past the corner or be held flush. For the first panel on a wall, you should have marks on the panel ledge to position the panel. You will need to put some goo on the ledge to seal it. Using the sausage gun, lay a tall bead of panel adhesive the length of the panel location. Have a flat bar, a mallet or hammer, and a level handy, as well as an impact driver with the proper bit. 2 people should be able to handle the panel on the ground level. They should be on either side, mid-span. Pick up the panel, either by hand or by machine, and walk the bottom over until it bumps the ribbon band. Then lean the panel up and hold it against the wall. While one person is holding the panel against the wall, the other can be tapping the panel to the layout marks on the ledge. Holding a 2x4 against the OSB will prevent it from crushing while tapping. Now the panel needs to be leveled. Determine which side of the panel is high and drive the lower corner screw on that side. The top of the panel can be moved over by inserting the flat bar under the low side. If it is a small adjustment, the top of the panel can be nudged while checking with the level. When it's good, drive a couple screws, then stand back and check that it fits the way it's supposed to. If it goes up to the roof line, the angle cut on the top should be about a ½ inch below the top corner of the beam. This allows room for a foam gap under the roof panel. Screw the board holding the lift straps into the OSB face of the panel about half of the distance between the center and top of the panel. This shows how one home builder used some blocks which their carpenters fabricated on site. The blocks were convenient for reaching the screws from the edges of the panels in difficult situations. Either way, be sure you have screws with threads actually in and through the OSB. Use robust screws such as GRK 5/16 by 2½ inch long. The panels are relatively light for their size, but having one damaged by dropping to the ground, or more importantly, having someone get hurt, is not worth the risk created by saving a few seconds in setting plenty of screws. You can also lift a single panel with straps held to the panel by a 2x4 or 2x6 with 6 screws. If you have pre-assembled 2 or 3 panels on the ground, use a long 2x6 for the straps and screw the board into each panel to keep the assembly from flexing in the air. You can also attach a rope or strap to hold the panel steady as it's lifted into the air. Or, a long 2x4 can be useful to steady the panel and then push the bottom of the panel to where it needs to be on the sill plate. Leaning a tall ladder against the panel also helps to stabilize it while the first 2 or 3 screws are driven home. At this point, you can insert splines into the slot, pushing the spline down from above. If the panel breaks halfway on a post or beam, do not drive the screws so much that they constrict or crush the spline groove. The plywood splines can be installed in their groove when the panel is up. If there's a horizontal seam at the top of the panel, make sure that the vertical spline is below the bottom of the horizontal groove. On the gable ends, the wall panels are usually stacked on top of the other. The horizontal seam should already have a spline in it. The first panel to be installed on the roof is the lowest. It will run horizontally and usually has an overhang. There is a detail in the panel plans titled Panel Eave Connection Detail. It should have a dimension for the overhang from the face of the wall panel. Trying to measure that distance while the panel is in the air is way too difficult. We usually make a full-size layout of that detail on the face of a panel, a large flat surface, and get a measurement from the outside edge of the frame to the lower bottom edge of the roof panel. Usually, the lower panel course on the roof is horizontal and full width, 48 inches. Deduct this measurement you just got off the layout from 48. That's the distance from the edge of the frame to the top edge of the panel. But don't rely on this measurement alone. There is another measurement to check first. On the panel detail page, look for the panel ridge connection detail. You'll see that there's a gap at the peak where the panels from each side meet. The gap is wider at the top and touching at the bottom where the panel rests on the rafters. The wider top gap is for spray foam. You'll need to find one of these panels with the ridge cut and pull a measurement on the bottom face, which rests on the roof. This measurement is then transferred to the roof face, where it's compared to the overhang measurement from the eave connection detail. If your roof panels are all running horizontally, you'll need to add up the number of panels by 4 feet to get the total run from the center of the ridge to the top edge of the first panel. You can also refer to the panel pre-cut plan, which shows the location of the back cut line and the dimension from the edge. Scrap 2x4s are nailed to the rafters as a guide for the first roof panel. The first roof panels will be pushed up against the 2x4s and screwed into place. Prepping the roof panels is much like the wall panels. On the top side of the panel, lay out the other rafter locations and preset the screws, keeping them out of the spline slot. If you've installed furring strips, like shown here, start the screws on the center of the beam, which would mean the screw is also driven through the center of the furring strip. Check your panel plan for exact details on screw spacing. Screws are usually 10 inches on center, so 5 across the bottom and 5 across the top. If the panel is half bearing on a post, keep the screws 2 inches from the edge. They need to miss the groove for the spline, but hit the post. You might want to angle these screws slightly. Do not drive the screws so much that they constrict or crush the spline groove. For lifting the panel, use 2 of the seatbelt straps threaded on a 2x4 or 2x6, then screwed to the roof panel about 2/3 of the way up the panel. Use at least 12 robust screws, such as GRK 5/16 by 2.5 inches long. The roof panels are much heavier than the wall panels, so don't skimp on these screws. Also, nail or screw on 2x4s along the bottom edge to provide some footing. You'll be standing on this panel to land the one above it. You might also find it convenient to temporarily screw the splines to the surface of the panel so they are near at hand after the panel is in place. After the first row is installed, the remaining panels will rest easily on the first row. Now is a good time to double-check the remaining distance to the ridge and make any adjustments. Structural panels usually run horizontally from end to end, with the panels laid perpendicular to the rafters. Referring to the panel layout plan, start with the bottom row and work your way to the top. You can set the splines in place on the lower panel and slide the upper panel down over it. Leaving the spline loose will allow you to wiggle or work the spline and panel into alignment. As you work up the roof, check your measurements for the remaining distance. The bottom face of the last upper panel should be right at the top center of the ridge beam. Time is usually a critical factor when installing the roof panels. Many times, a crane will be hired for the day, and possibly extra help as well. There are ways to save time. As long as the first eave panels are secure, the splines can be left loose, and the remaining panels can be placed with a few screws each. After all the panels are in place, you'll have more time to screw everything down and nail off the splines. Once that's complete, you'll drill and fill the roof panels in the same manner as the walls. Refer to the plan details. Roof panels are drilled 6 inches on center. Inject the foam, then get off the roof till the next day, when you can easily scrape off the excess hardened foam. All exposed panel edges will be stuffed with wood blocking, depending on the wall and roof panel thickness. 2x4s or 2x6s in the walls and 2x8 or 2x10 in the roof edges. All blocking must be the full length of the panel edge and must be one continuous length wherever possible. On the edges of the roof panels, do not allow the blocking joints to fall on or near the panel joints. Offset them by at least 2 feet. Anywhere you have foam to wood contact, put a bead of sealant. A bead behind every 2x is the rule. See plan details for panel mastic application, indicated by a red dot. All window and door openings have the foam cut back 1.5 inches. This space will be filled with 2x4s or 2x6s to stiffen the opening and provide nailing for the window and trim. Before you insert any 2x's, make sure all the splines are installed above and below the window opening. The foam at the corners is rounded, so you can either chop the rest of the foam out to make a square corner, or simply cut the 2x4 a bit short and fill the gap with expanding foam. At this point, you can nail through the OSB into the 2x or screw the drywall side. Some builders like to tilt the bottom sill board at 5 degrees toward the exterior of the wall. Just make sure to have the exterior of the sill flush with the exterior OSB so that the window will fit in the opening. Then, you may want to caulk or tape the opening to keep rain out of the panels. Rain will soak down into the foam and will take quite a while to dry out. You can also cover the entire opening with plastic until you're ready to install doors and windows. After the panels are installed, it's time to seal everything up. We recommend waiting until all the panels are installed, just in case you need to make any adjustments or changes. Save the foaming until after the roof is on. The foam is very messy and sticky, so it's best to do the entire wall, including the foam gap, just under the roof panel, all at the same time. There will be a panel plan detail which shows the drill and fill technique. You will be drilling 3/8 inch diameter holes every 10 inches along each of the panel seams, through the splines and into the foam channel. Make sure your drill bit goes in at least as deep as the channel. Deeper is fine. The foam will expand lengthwise into the channel. Stick the nozzle into the hole and count to 5. Then move on to the next hole. Foam will expand back out of the holes. Don't touch it. Let it dry for 24 hours when it can be easily scraped off. As you start filling the next hole in line, you'll see the foam start to push out of the previous hole. That's a good sign. It means the foam channel is filled. The foam gun has an adjustment knob on the end of the barrel. This is used to vary the size of the nozzle opening. It should be rotated counterclockwise a couple of turns to wide open when filling drill holes. When you're foaming open gaps, the flow rate can be reduced as needed to make the job more manageable. In between uses, simply rotate the knob clockwise to close the nozzle. Do not remove the can even when empty, unless you immediately replace it with a new can. Never leave the gun without a can installed. If the nozzle is shut between uses and a can is attached, the cans will remain good for many weeks. It is impossible to clean hardened foam out of a gun, and it only takes a few minutes for this to happen. Keep the can on the gun. The top angle of the roof panel is deliberately cut a little wide to create a gap which will be filled with foam. Roof panels are drilled 6 inches on center. You'll drill and fill the roof panels in the same manner as the walls. Refer to the plan details. On exterior deck locations, solid blocking is installed continuously wherever an exterior deck or porch will be attached to the house. This detail is shown on the plans and in the owner's manual as detailed D1 or D1A. The panels will come pre-cut to fit around this blocking. Before installing the panels on top of this blocking, it's a good idea to wrap some peel and stick membrane, ice and water shield or similar over the blocking, lapping up onto the rim board and down over the edge of the sill or panel shelf. Make sure the plywood rim furring is behind this blocking and at least 1 inch beyond the edge. Later, put a layer of membrane over the blocking prior to installing the deck ledger, and then flash the deck framing. We strongly recommend a vented roof system for all houses. The owner's manual covers vented roofs in detail, and your plans will have specific eave and rate details for your project. Do not consider this as a needless expense, but rather as cheap insurance. Regardless of how carefully the panels are sealed and finished, over time, small hairline gaps will open up and moisture will migrate from inside the house through those cracks. A vented roof allows the moisture to dissipate harmlessly. It also keeps the surface of the roof cool in the summer, which prolongs the life of your roof. We feel that a vented roof is not an option, it's a necessity.